Right, let's start. Hello everyone, welcome to our first backend meetup at Supercharge. I will demonstrate how we run serverless in Google Cloud using Micronaut and Kotlin. Let's begin. Okay. How can we do the right things in an easier way? This is a question we always ask from ourselves as a developer. And how can we develop backend applications in an easier way? Let me show you an answer with Google Cloud and serverless programming. What you will hear today: what is cloud, who are the main providers, what we like about Google Cloud. After that, how we went serverless, why you should consider serverless programming, what are the main use cases. After that, I will join the first two topics. What options are in Google Cloud to develop serverless applications? We'll check out the Google Console together. And finally, I will tell why we chose Micronaut and what our experience is with it. And I will show you how to create and deploy a simple Micronaut GCP application. Sorry, I accidentally skipped the slide where I introduced myself. That's why I am embarrassed. So my name is Flamis, and I am a Java developer since 2015, and I work at Supercharge since 2020. And yeah, I tried out Google Cloud and Micronaut in the recent past, and I will show you that today. So yeah, late introduction is done. Okay, what are the main cloud providers? The first one is AWS. It has the first mover's advantage. It has the largest ecosystem of third-party tools and partners. It has nice documentation, dashboard, and it can be used really easy. The second one is Azure, which is the Microsoft product. It also has strong offerings if you want to go to the cloud. It does the job. It can be junky sometimes. It has downtimes. In the recent past, it had really big downtime. So yeah, it has its issues, but we like it. It's easy to use as well. And the third one is Google Cloud, which is the third biggest one. We tried out this, and let me go in detail. What is Google Cloud? Google Cloud Platform is a runner-up in this industry. It runs our services, our servers in the same infrastructure as it's running its own services like Gmail and Google Search and YouTube. So it's really nice to know that your service is running on the same infrastructure. And also it has strong offerings in platform as a service, infrastructure as a service, function as a service components, and often considered the most competitively priced of all three. So all three biggest providers. It's really cheap. You should try it. It has a wide range of services. I couldn't fit it in the single picture. There are many more, like networking, security, developer tools. And we are focusing tonight on the compute parts, which are these three. But first, let's talk about what is serverless programming. I'm sure you are familiar with it, but I wasn't, so let me tell you. Does this mean that you now run code without servers? Well, not exactly. You still have servers. You just don't have to you don't have to manage the underlying infrastructure. Everything is done by the provider. You just have to focus on your code and deploy it. Why is this good for us? Because we can go live faster and test the market sooner. And also it increases the productivity of developers by letting them focus on the main thing, solving real business problems. Function as a service. You will hear this term a lot if you want to work with serverless programming in the cloud industry. It can be referred as FAS, it's the short version, and it is a model for implementing serverless applications. The key aspects are for developing serverless applications is that you don't have to worry about managing the infrastructure. You don't have to install networks, configure security. You don't have to install packages. Everything is done by the provider. You just have to focus on your code and deploy it. These FES functions also event-driven functions, and they can be triggered by message queues, pub subtopics, or HTTP triggers. They are really scalable, and they are automatically scaled. So you don't have to come up with plans for high user demands. The provider does the scaling for you. They are usually stateless, and it's easier to manage if they are stateless. It's not necessary, but it makes your life easier if these functions are stateless. Also, they have short lifespan. Their execution time is limited. It can be 5 or 10 minutes, so that's one thing to keep in mind. Where can you use serverless functions? Well, you can implement microservices with it, where every piece of function implementing pieces of logic. We done this in one of our projects, and yeah, every API were in a different function. Also, you can use it as a data processor. It can execute the responses of changes in data. We implemented one function which was triggered by a file upload in a storage bucket. If someone uploads an Excel file in that bucket, our function will process it and save the data in the Firestore database. Also, you can connect to IoT devices and process the real-time data, and you can get notifications from your sensors. Another use case is that you can extend services. You can listen to webhook events. For example, if a GitHub issue is created, you can listen for the webhook created, and your function can post a detailed message about the GitHub issue in the Slack. So it's really great. Let's go back to Google Cloud, and let me show you what options Google offers for going serverless. Well, there are 3 main options. The first one is App Engine, which is designed for multi-purpose functions. It can have multiple endpoints. It's better suited for modern web applications. It supports some languages. Not many, but it supports some. Also, there is Cloud Run, which is built for serverless, which is running serverless containerized applications. You can put your code in a Docker image and deploy it, and the cloud provider, Google, will manage it. And you don't have to do anything with it. You just deploy it and it runs. And you can use any number of languages because it is in a container. So it's really nice if you want to use some extreme language, programming language. And the third one is Cloud Functions, which are single-purpose serverless event-driven functions. Yeah, and the Cloud Functions are the cheapest one of the 3. We tried out Cloud Functions because it was the cheapest one. It was the simplest one. And this is the advantages we found with Cloud Functions. As I mentioned, they are automatically scaled. You just had to set the minimum number of instances and the maximum number of instances you wanted to allow, and Google will manage this scaling. Also, you can use the integrations very easily. There is a marketplace in Google Cloud where you can enable these kinds of services by one click, and you got an API key, and you are good to go. I will show you that marketplace. It's really simple to use. Also, it can be triggered by a variety of events. There are 90 or 100 events that you can choose from. We tried out HTTP triggers and scheduled ones. We have functions which are scheduled ones. And also we tried 1 or 2 functions which are triggered by topics, message queues. You can use 6 or 7 languages. The main ones, the .NET, Node.js, Python, Go, and Java. And it was great for us because we are developing mostly with Java. The disadvantages were, it can be really complex to understand your project. In our project, we have 26 different functions, and it can be hard to find the logic that you are looking for. Sometimes it can be hard to debug your project. Also, it can have cold start problem. When a function has not been invoked for a while, it can take longer time to start up when it first invoked. Yeah, and the user can experience 5 or 6 seconds of response time, and it's not the best. But it can be avoided if you set your minimum instances more than 1, but it's not that cheap then. It's not the cheapest solution. Also, it doesn't support many languages, so maybe it's not the best fit for you. And their maximum execution time is maximum 9 minutes. So that's a thing you have to keep in mind. All right, I will show you the dashboard quickly in my browser. You will spend the most of the time if you are working with Google Cloud here. So you can create and edit projects. You can manage your services. There is a section for every kind of component here. Also, you can see your billing account and etc. There are lots of things. Let me show you cloud functions. I have some example functions. Most of them are triggered by HTTP calls. There is one I created which is triggered by on a message from a test topic. And as you can see in the right, you always get nice tutorial and documentations for every kinds of pages. If I click here, it will guide me through how to create a function. And yeah, it's very easy to use. It's helpful. So let's create a function, not with Google Help. Let's close it. You can name your function. You can set the region. Very simplistic UI. You can choose the trigger type. If you are staying with first gen Google functions, you are only getting 9, I can see 8 trigger types. But if you change to second gen, it offers much more. You can use an event art trigger, and lots of events can be chosen from. But for the simplicity, let's stay with first gen. Also, you can see here, second generation offers much more concurrency. You can use more events. The execution time is raised for 60 minutes, and it's available in 2 more regions. So it's a little bit better one, but it's running on Cloud Run, and it's not Cloud Functions anymore, or I don't know. Okay, let's save the HTTP trigger type. You can choose how many memory do you want to allocate, what is the timeout, the execution maximum. Here you can set the scaling, auto-scaling. You can set how many instances do you want to allow. I hope you can see it. It's really small. And yeah, you can control what traffic do you want to allow on your function. You can set secrets, and yeah, you can get an inline. Google offers an inline editor for this. You can choose from the languages. Let's stay with Java and deploy a simple function which writes hello world. Also, you can do it from your console, of course. I will do that later. I just want to show you how easy to use this Google UI. Let's deploy it. After the deploy, you will get a nice metrics page where you can see the invocations, the execution time, the instance count. Also, you can check the details of your function. You can get the source code, see the variables, check the trigger type. permissions and logs. You can see the debug logs here if you want to debug something in your application. So it's very convenient to use. Let's not wait this. It's not that important right now. Okay, let me show you the billing account. You can get a free trial when you register the Google Cloud, which is $300. You can experiment with things. It's a lot of money if you are working with Google Functions. I'm using it since 3 weeks and I get 8 cents of charge, so it's really cheap. After that, I wanted to show you the marketplace where you can enable APIs. For example, if you need Google Maps API, you just search for it. And you can click it, and it will enable the API in a matter of seconds. After that, you can generate an API key, and that's it. You can use it in your application. There is nothing more to do. All right. Ooh, that's my API key. Don't look. Let's go back to the dashboard. I saved the slide to show you. I find it amazing that if you forgot to enable some API, Google will remind you, and you can enable them by one click. I think it's really nice touch in this dashboard. Okay. So we asked ourselves, how should we develop serverless? We worked mostly with Java or Kotlin language. We are developing backend applications mostly with Java or Kotlin languages. And so therefore we have our methods and tools to use that. For going serverless, we tried Spring and Kotlin. They were slow and they are not that great, and Kotlin already got deprecated. It's the JetBrains product, and yeah, it can be used now. Or you can use it, but it's deprecated, so it's not that good. And so we needed something fast and lightweight. Therefore, we have chosen Micronaut. But why, you can ask? Well, it is designed for building cloud-native applications. There is a sub-project in Micronaut, which is called Micronaut GCP, which is built for exactly Google Cloud. And yeah, it can be easily used, and it has a nice documentation. Also, it's fast, efficient, and really lightweight because it offers ahead-of-time compilation. Also, it has a built-in HTTP server, so you can try out your functions locally, you can debug them and run them easily. And it's very similar to Spring. You don't have to relearn everything from the ground up. You just download the application and you can use it easily. You can develop these Micronaut applications on day one. It's really similar. It also has a nice initializer page as Spring has. You can choose your application type, which can be a function application for serverless. You can choose Java version. You can name your application, select the versions. You can preview the features, and you can generate your project. I already generated a project, which I wanted to show you. I'm not going into the details. I just want to show you how easily can this project run locally, and how can you deploy it in Google Cloud from your terminal. All right. This generated project has 2 endpoints. The one is the example which I got from the Micronaut generator, and the other one which I wrote, which gets a request. It gets an address, and it will return using the Google Cloud Validation API, address validation API. It will return the latitude and the longitude of that address. As you can see, it's really similar to Spring, it has controller annotations, get and post annotations, it has body. You can inject your beans or services in here. It offers an HTTP client, which is really similar to Fein client in Spring, and it's basically the same. It uses interfaces. I like it very much. Also, it is an application YAML where you can write your properties and read that properties with configuration properties. It's basically the same as in Spring. So yeah, I was serious when I told you that you don't have to relearn anything here. Okay, let's start it. You can easily start it by Gradle. You just start this run function command and it will start it on your computer. All right. After the initial build, it will be fast. Yeah. Nice. Okay, let's call it and see if it's going back the coordinates. I will call this address. Oh, it's not calling the localhost right now. Let's change it. Let's call it. Yeah, it returns a latitude and longitude. Let's check it out if it's working, but I hope it's working. It's not my fault, it's Google's fault. I'm using validation API if it's not working. Oh, where is my answer? All right. Yeah, it looks like it's Tapolca. I can recognize it, I grew up here. So yeah, near Balaton, nice. All right, what I wanted to show you, how can you deploy this into Google Cloud? Well, first you have to build a fed jar, or in here called shadow jar. Let's clean it first. Okay, I can find a clean. And after that, you can create this shadow jar, which is a combined jar of the project and the runtime dependencies. It's just a big jar with everything in it. All right. Here is the jar, which I will deploy. And this is the command I will use. You don't have to use pipelines, you don't have to overcomplicate things. You just enter this function and you are in production. But it can take a while. It can take up to 2 minutes. And I'm waiting for a question. Okay, it doesn't ask it. So let's go back to the slides until then it's deployed. There is nothing more I will show you. So let me summarize what I wanted to give you today. Google Cloud allows going serverless on these 3 options. You can use App Engine, Cloud Run, and Cloud Functions. So yeah, and we tried out Cloud Functions. It was really easy to use. It was cheap, and it worked for us even if we have lots of functions. As I mentioned, we have 26 already in a small project. It can work in a small project. Also, we tried out Micronaut because it's fast and consumes less memory than the competition, and it was easy to transfer from Spring to Micronaut. It was just this. All right, let's go back. I hope it's deployed. No? I will show you. Let's create the HTTP call until then. But I don't know the URL right now. Okay. It's not that interesting, but I will show you. All right, Micronaut, right. Let's try a different address this time. Well, Budapest, Károly, Körút 9. We are here. It's no problem, because I named my function Micronaut Guide, and I have a controller in it which is on the Micronaut Guide part. So, yeah, it was a lazy work from me. All right. We have experienced the cold start problem. It took 16 seconds to answer because there wasn't any active instance, and it gave back the location after that. But if I call it right now, it will be much faster. Let's check it out again. It's interesting. I'm always excited to see where am I. All right, we are in Budapest. That's great. Okay.
So the 16 seconds was the cold start?
Yeah. So you have to keep that in mind. It can be slow sometimes. And maybe you have to set the minimum instances in a higher number than 0. But if you are not using that function that often, it's better to shut it down, because it doesn't cost money then, if you are not using. So that's it. Thank you for your attention. That was me and Cloud Functions. If you have any questions, let me know. I will be here, and you can ask them now.